Okay, so writing net ionic equations, there's a few steps you need to do it. The first thing, you have to take a look at the reaction that you're starting with. If the reaction does not tell you which of your two products is solid, you have to use your flowchart to first identify what the solid's going to be, if you even have one in this product area. Okay, so if I look at the flowchart that we did in class, I'm going to follow. So I'm looking at this first one here. So CaPO42. So following my flowchart, the answer is no to this first question, no to the second one, no to the third one, no to the fourth one. But it does contain a PO4, which means that yes was the answer here, which means it's insoluble. And remember guys, insoluble means it's going to be the solid. So if that's the solid, then I can write the S next to that product. So now I know what my product is going to be in terms of the solid, meaning the other one is going to be aqueous. You can never have two solid products, okay? So now we know what the solid product is. We can take a look at the complete ionic equation first. So for the complete ionic equation, what we have to do is break apart all of our reactants and our products into their ions. Okay, so taking a look at this first one, we have 3 CaCl2 molecules here. So that means that we have 3 calcium ions. So I'm going to write 3Ca, okay? Remember, they've split apart into their different ions, so that means it's going to carry this charge of calcium. So there's a couple ways we can find the charge on calcium. We can backwards cross-charge, so this 2 came from the calcium. Or we could look at the periodic table and it's in the second column, so that tells us it's got a 2 charge. So either way, we know what the charge is. And we cannot forget that this is dissolved in solution, so we call it aqueous. Okay? On to the next one. We have 3 of these molecules, and for every one molecule we have 2 chlorines. So 3 times 2 means that we're going to have a total of 6 chlorine ions floating around. Chlorine on the periodic table tells us we have a -1 charge, and this is aqueous as well. So that's that molecule. Moving on to this one, we have 2 times 3, so 2 times 3 is 6 sodiums floating around. Okay, so because we have, for every one of these molecules, we have 3 of them, and we have 2 of those molecules. Sodium on the periodic table has a positive charge, and that's going to be aqueous. And then
Joshua Bateman, please report to the bus loading zone. Joshua Bateman, please report to the bus loading zone. Thank you.
Alright, so now PO4s, in terms of PO4, we have 2 of these molecules, which means we have 2 PO4s. And if you don't know what the formula is for phosphate, for PO4, take a look at this 3. It cross-charged down, so that means that phosphate has to have a -3 charge, and again, this guy is going to be aqueous. Okay? So that's all of our reactants separated into their ions. And now we can take a look at the product side. So I don't have room to write it all in one line, so I'm going to skip down here. So take a look. This guy's our solid. So because it's solid, we do not break it up into its ions. We just leave it as is, as the solid. Okay? And then on to the next one, we've got the aqueous NaCl, so that means we have 6 NAs floating around. Oh boy, I didn't write the 6. And that's going to be dissolved in water, so it's aqueous. And then we also have 6 chlorines. Okay, so 6Cl minus aqueous. Okay? So that's the complete ionic equation. It involves all of the ions floating around in solution. The net ionic equation only involves the ions that make the solid product. So now we're going to take a look at, okay, what did not help me to make my solid product? So let's take a look. So the sodium obviously isn't involved, so I'm going to get rid of the sodium on either side of the arrow, so before and after the arrow. And the chlorine's not involved either, so I can get rid of that. The calcium was involved and the phosphate was involved, so I leave those alone. Now I take a look what's left over, and I just copy it down into the net ionic equation. So I have my 3Ca2 plus left, and then I have
Attention, testing.
my
Thank
2 PO4, 3 minus, and then my solid Ca3PO4, solid. And that's my net ionic equation. Okay? So remember guys, you just have to go slow with this. Remember, if you don't remember how to do the double replacement reaction in terms of writing the formulas here, I have a previous video on that, so you guys can look back at the other video. It's called double replacement reactions. But really, it's quick. Once you get good at it, it becomes quick. You just have to practice a lot. So if you have any more questions, come see me during lunch or break, and I'll help you out.